two solutions because of this situation. All the other triangles we just talked about had one solution. There you go, folks. I mean, this is without getting into and forcing you to figure out right triangle geometry, to figure out heights and where this bisects this line over here and all that kind of stuff, which is fun to do. This is a good summarization of when you have the potential for no solution or two solutions or one solution. So for angle, side, angle, or side, side, angle, rather, when A is less than B, these are the conditions that you have to check. This is side, side, angle, and this is comparison of A versus B. But when you got A less than B, you got some further checking. So there you go. This is not on your sheet, I suspect. I don't remember seeing it. I don't even know why it would be on a trigonometric identity sheet. This isn't an identity. The law of cosines and law of sines, yes, but this is not. This is an application of that. So unfortunately, you're going to have to remember those. If you have a question, you just scratch it. Is that all right? So let's go through some examples here. But once you make that determination of this, then you know, everything else that we've been talking about just applies per normal. All right, so let's see if I can. All right, so this is going to be per or a la, not. This is going to be how the homework is presented. So let's practice that part of it too. So I give you little a is equal to 10 degrees. Capital A is equal to 10. Capital B is equal to 20. First question you ask yourself is self. Which of these three relationship conditions between A and B does that fall? Which of those three A-B relationship categories does that problem fall into?
The difficult one?
Yeah, you're on a roll. So it's this one. A is less than B. You guys are just shy. Last time I checked, 10 was indeed less than 20. All right, so now you're over to here. Now, with these conditions as I presented them, you're going to need to do some computation because unless you're a whiz-bang trigonometric guru, which I seriously doubt anybody in here is, and only in the sense of being able to compute the sine and cosine of any of the infinite number of angles that might get thrown your way, you're going to have to do some calculation. So what are we checking here? We're checking A against B sine of A, right? So we then need to figure out what B times the sine of angle A is. So this is equal to 20 times the sine of 10. Anybody want to tell me what that is?
How many decimal places? 2.
Let's go to 3.
3
Live on the edge.
3.473.
Alright, so that's what B sine A is. Right? Now you check the relationship with respect to A. A's this, now we got this. So which of those three conditions does it fall into?
The difficult one?
So A is greater than 3.473, correct? 10 is greater than that, so we just change this to 10. So that implies that there are two solutions. So now you know you must find two solutions. So, yeah, it has a little bit of nuance in the sense that it maybe forces you to remember these a little bit, but I think it's worth the effort because, like, two reasons. One is I said, just, you could do it relative to a generic triangle, but you would have to do some calculation of its height and all that. So this is much easier to remember. And B, it takes away, or let's put it in a positive case, it gives you the absolute answer, like how many triangles are you looking for? 0, 1, or 2. So now you know you got two. So okay, now you fine. So now our triangle then is like this. So here is, this is our little A, this is A, and this is 10. This is B, this is B, this is 20, and this is C, and this is capital C. So we've got A, B, C, A, B, C. And this isn't drawn correctly, right? So A was 10, B is 20, and A is 10. So we got side, side, and so what would you do here, you think?
Use the law of sines.
So let me just, so let's see, could we do cosine? It would be c squared is equal to a squared plus b squared minus 2ab times the cosine, no. And then here, cosine A, we need A, and so no, so law of sines. So that would be what? The sine of A is to, the sine of A is equal to A. So this would be the sine of 10 is equal to 10. It's confusing because both the angle and the length are equal to 10. And that's equal to the sine of little b, which is capital B, which is 20. So little b is equal to the inverse sine of 20 times sine 10 divided by 10. And that's going to be equal to what? .232 for B. Is that what everybody got?
I'm off by 0.02, but that could just be rounding error.
You're off by 0.02. What'd you get?
20.303.
Well, no, I hate to break it to you, but the way this problem, this computation right here is done, those are exact numbers, no rounding error in there at all, until the very end. So it must be an operator error.
Well,
Did you get 20 point. Did everybody get 20.332?
When you do the sign of 10 times 20, you get a very long decimal. It told me to go out to 3 decimal places, which is what I did. And then,
Oh, no, okay, now you just introduced round off. Round off at the end.
oh, well, you never told me.
Yeah, I did. I said, you do that at the very end to avoid round off. So yeah, now that I would explain. All right, so now anybody want to guess what C is?
149.678.
149.678.
Yeah.
And then from that, you can compute C, which is what? C would be 29.06. So there you go. Now, the problem that we discovered last week, or whatever it was, is that there's an ambiguity here, right? And our little check told us that we needed 2 solutions. So when you found this angle B, and again, it's relative to the diagram that I erased, but if we have pulled this angle to side B, you're gonna have the possibility to get a different triangle, because we figured that this was going to be, so A was 10, B was 20.322, and then C was this. So, but not worried about that. So when we took the arc sine to get this, you're always going to get the acute case, always. So, but because of that property that I showed at the beginning, there's 180 minus this number, which is the complementary angle, the obtuse angle for that acute angle. So this B could be this instead, and that would give you your second triangle. So that would turn out to be, that would be turn out to be like 159.680 or something like that. So there's your second triangle. And then if you figure out C, it would be 10.32. That's angle C. And then the side C,
So what's the formula with the 2 solutions again?
formula.
Yeah, you said like there was some, like how did you get the 180 minus the 2 point?
Well, first of all, you realize the condition we used to determine that there was 2 solutions. So once we determined there were 2 solutions, you go about the problem, in my opinion, per normal. But the first thing, you got side angle, you're gonna be finding one of these other 2 variables, okay? But it's pretty much going to be B that you're gonna find because of the law of sines, right? You have to make use of this angle, it's the only one you got, and you have to make use of that side because that's the side opposite to it. You have no choice. So this angle right here is the angle that's gonna have 2 values, an acute or an obtuse, right? Get a grand slam. Okay, so far with that? So when we went through this normal process here for B, does everybody follow what I'm saying? Is that with a side angle,